Alright guys, you'll need a extra sheet of paper, like I told you yesterday. So make sure you have a sheet of paper out. If you need to pause and get a second to get a sheet of paper out, go ahead and do so. So today we're finding the inverse of matrices. And when you find the inverse is just a reciprocal. And you know, like if we have 8, then the reciprocal is 1/8, and then the reciprocal of 1/8 is 8. So it kind of goes around and around. So if we let the matrix be called A, and all of our little elements in there is A, B, C, and D. Okay? So we don't divide matrices ever. There's actually not an operation for division. So since we don't divide, you multiply by your inverse. That's just like if we had, let's say for example, we had 1/8 x equals 2. You would multiply both sides by the inverse in order to get rid of this 1/8. Okay, so it's the same thing, same concept. You're not going to actually divide, you're going to multiply by the inverse. So we say that the inverse is going to be called a to the negative 1. Okay, so everybody knows that if I raise 8 to the negative 1 power, that's going to be 1/8. So that's the reason why we say a to the negative 1, because I'm actually going to take this matrix and basically flip it. Okay, so the way that we do this, so to find the inverse of our matrix A, so I'm still using this matrix up here, we're going to take the determinant. So I'm going to say A inverse is you take the determinant. So y'all know how to take the determinant. Take the determinant of your matrix, and you're going to multiply that by, you're going to swap your two corners. So A and D are swapped. Okay, I want to go slow through this so that you understand what I'm talking about. You are swapping these two corners. They are switching sides. They are not changing signs. They are just swapping places. And then the other two corners, you're going to change their sign. Okay, so you notice that C and B, they now become negative. So that's what you're doing in order to find your inverse. And we're not going to do that right off the hand, but I want to make sure that you have notes on this stuff. So then if the determinant is 0, I had mentioned this before, it does not have an inverse. So if it says find the inverse and your determinant is 0, well, obviously you can't divide by 0, so you can't have an inverse. So there's just no inverse on that one. So in our calculator, we can actually put our matrix and then raise it to the negative 1. So in other words, you're going to put, an example would be in your calculator, you know, when you put your matrix, it puts the little brackets around it. So you would put A and then raise it to the negative 1 power. And that's actually on your calculator where we always hit matrix. There's your inverse button right there. Okay. So it's going to be really easy to do these in the calculator. We're going to do a couple by hand real quick. Okay, so for number 1, we need to find out what the determinant is in order to see if it has an inverse. If it has a determinant, then it has an inverse. Okay, so this, to find our determinant, remember that you're going to multiply your diagonals. So that one's 0. And you subtract when you change direction with your circles. And that one's 0. So the determinant is 0. So does it have an inverse? No. Okay. So on this one, and on these, it's really easier to do these to see if it has an inverse by hand rather than take the time and actually input the matrix in the calculator. So that one's -6. Okay, so this is -3. So it does have an inverse because that is not 0. So yes, it does have an inverse. Okay, so then it says find the inverse of the matrix by hand. Now we're only going to do 2 of these really. And then after that, you're going to be able to use your calculator. I just want you to be able to see how to do this. So when it says to do it by hand, you're going to find the determinant first. Well, this is going to be 0 and this is going to be 0. So is it going to have an inverse? No. Well, that was easy. Okay, so technically we're only doing it once. Okay, so first you need to find the determinant. So this is -30 minus 56 equals -86. So it definitely has an inverse. Okay, so we're going to take 1 over our determinant, which is -86, and it's going to get kind of gross because it's got fractions in there, but don't freak out. So we're going to multiply it. Remember, you swap. Let me erase my circles so you can see it better. You're going to swap this corner. So they're switching places. So -5 comes up top and 6 is on the bottom. And then you change the sign of the other diagonal. So this is a +7 now and a +8 now. Okay, and you can multiply these in your calculator. So, and I would love to have fractions, because if you do decimals, then it's going to get really long and not look good at all. So if you're multiplying by -86, you're basically dividing by -86. So I can take -5 divided by -86, and it gives me a horrible decimal. So I can do math, enter, enter, and it changes it into a fraction. Well, you probably knew that you couldn't reduce that one, so it's going to be 5/86 in that spot. Okay, and then I would do the next one. I would do 8 divided by -86. Change that. Math, enter, enter. So that one could reduce. So it's -4/43. And keep doing that. You get -7/86. And then -3/43. Okay? So that's how you find it by hand. It's really not that bad. If you wanted to go back and double check once we find out how to do it in the calculator, then you'll be able to see how to do that in just a minute. Okay, so it says on the next part, find each one using the graphing calculator. Okay, so that means that we need to plug this in. Matrix A is what I'm going to call it. So there again, second matrix, go over to edit, hit enter for A, and A is a 2 by 2, which is nice because it has to be a square matrix in order to have a determinant. So in order to have an inverse, it also has to be a square matrix. So 3, -1, -1, and 7. Okay, so get out of that. And then you want to be on the home screen in order to find the inverse. So what you're going to do is tell it which matrix you want. We want matrix A. And we're going to take the inverse. So I'm just going to hit the x to the -1 button. And then you hit enter. And it gives you decimals. I don't want decimals. So you do math, enter, enter, and it changes your whole thing into fractions, which is pretty nice. So then there's your answer. And the reason why I definitely want you to have fractions is because your homework answer keys and stuff, they all have fractions as answers. So it'll be easier for you to check it. Okay? All right, so go ahead and try 6. And when you come back, I'll give you the answer. So you probably put this in as matrix A in your calculator. And you got 5/71, 4/71, -2/71, and 11/142. Okay. All right, so on 7 and 8, it doesn't say to do it by hand, so I'm not going to do it by hand. When it says to find the inverse, that just means that we need to find the determinant. So if it exists. So we need to see if the determinant is equal to 0 or not. So we're going to enter these in. There again, I like matrix A. You could put it in as matrix F. It doesn't matter. It's easier to grab matrix A because it's the first one. So that's the reason why I tend to use it all the time. So for 7, that is a 3 by 3. And then just put in all the information. Okay. Get out of that, and we're going to do the determinant. So find your determinant. Remember that's under math, and it's your first one. And then tell it matrix A. And it's 24. So does this one have a inverse? Yes, it does. Okay, so try 8, and then go ahead and try to do 9 and 10 on your own. So do 8, 9, and 10, and do it all in the graphing calculator, and then pause it, come back, and I'll give you the answers. Okay, so 8 was 30. So yes, it does have an inverse as well. Number 9, your answer should be -1, 0, 0, -49 over 17, -6 over 17, 5 over 17, -6 over 17, 1 over 17, and 2 over 17. So the determinant was probably 17, if I had to guess. Okay, so number 10. Hopefully you already did that one as well. If not, pause it and catch up. 1 over 6, -1/6, -1/6, 1/4, -1/4, -1/4, 0, -1/2, 0. Okay, so today's going much quicker because it's just so easy to put these in the calculator. All right, and on the back, we're actually solving these. When you're solving these, you want to make sure that you multiply by the inverse when you're dividing, because you cannot divide, even by a whole number. There's no operation for division. So when we want to get this 4 on the other side, you would normally divide by it, but since there's no division in matrices, you're going to have to multiply by the reciprocal. So the reciprocal of 4 is 1/4. So we're going to multiply both sides by 1/4. So, I mean, it'd be easier to just distribute this to each term than it would to be put it in the calculator because it's just one matrix. So then I get B equals -9, -8, and 3. Okay, so you can put it in the calculator if you want to, but for this one you're just multiplying 3 numbers, so it's really not that bad. Let's go ahead and look at number 12. On 12 it says C minus a matrix equals another matrix. So we can go ahead and label this A and B and plug those in our calculator in a second. But what we need to do in order to get C by itself, just like if you had a normal equation, you would want to make sure that you get C by itself by adding matrix A. So we're going to add matrix A. Okay, so when we add matrix A over, we're going to end up with C equaling A plus B. Okay, so when we enter it in our calculator, we're going to edit A, and we're going to make sure that it is a 4 by 1, which I already had in there, and it is 7, -1, -9, and 8. And then you're going to go over and do matrix B and change it. Now that one is a 4 by 1 also, so make sure you change the size first and then enter your data. Okay, now that they're both in there, you want to get out of that, go to your home screen. It's easier to clear everything out so that you have a fresh start. And we're going to actually do just what it says. It says C plus, or C equals A plus B. So we're just going to do matrix A plus matrix B. And then we'll hit enter. And that's what C equals. So that's our answer. So then C equals 11, negative 6. Should have made that bigger. 11, negative 6, 9, and 10. And it is also a 4 by 1, which makes sense because when we add or subtract, we always keep the same dimensions. It doesn't change our dimensions on any of those. Okay, so 13 is just slightly different, only because you've got a little bit more going on. When you think about it, I always label my matrix first. So I'm going to just do A and B again. And then in order to get C by itself, it's just like if we had one that was negative 2C minus 5 equals 10. Well, you would add 5 first, and then you would worry about that 2. So that's what we're going to do with these matrix operations also. First, you're going to add matrix A. So I'm just going to start doing this because it's easier. So matrix A, because this was a negative, you want to make sure that you add it in order to get rid of it. And then after we add matrix A, we're going to multiply, because we don't divide, we're going to multiply by what? Negative 1/2, because that's the reciprocal of 2, or negative 2. So then what we're going to be left with is C equals, you're going to have A and B added together on the other side, but you're going to have this negative 1/2 multiplied by the whole thing, multiplied by A plus B. Okay, you can use parentheses there if you don't like using those brackets. It might confuse you a little bit using brackets, so parentheses are fine. Okay, so that's what we're going to do. First, we got to make sure that our matrix are in there. So you're going to edit matrix A, and matrix A on that one is a 1 by 2. So 7 and negative 2. And then again, just make sure that you enter what's inside of it. Don't worry about anything that's outside of it. So that negative that's outside, you don't have to worry about. So 1 by 2 on the other one. Okay, so I'll clear everything out. And then, like I said, that we're going to do negative 1/2. So we have a fraction, so it's going to be negative 1 divided by 2. Always put your fractions in parentheses. And then you're going to multiply that, and you need to put A plus B in parentheses because it's going to need to do those first. So matrix A plus matrix B. And close your parentheses there. And then just hit enter. It gives you your answer. So you're soon going to get pretty good at these. So this equals 4, negative 8. Okay? So go ahead and try to do 14 on your own, and then when you come back after you pause it, I'll give you the answer. Okay, 14, you should have added, if this was A and this is B, you should have added matrix A and then multiply by 1/5 to get rid of that 5 out front. So we've got Z equals, this would be your final answer, 4, negative 4, and 0. Okay, so like I said, you should add matrix A over and then multiply the whole thing by 1/5. All right, so 15, is a little bit different because we don't have anything to add or subtract, and we have a matrix that we actually have to move over to the other side, and it's being multiplied by C here because there's no operation in between the two of them. So we've got to make sure that we remember that we can't divide. We don't divide in matrix operations, so you cannot divide. So you multiply by your inverse. Okay, so you're always going to, anytime you have a matrix that you're wanting to get rid of, you're going to multiply by the inverse of that matrix. So that means we got to find the inverse of the matrix. Well, good thing is that we can just do it in the calculator. So you do need to go ahead and put in, we can call this A and B. Go ahead and put both of those matrices in. real quick. First one is a 2 by 2. And then the second one is a 2 by 1. Get out of there, go back to your home screen. And then when we're doing this, the way that you'll put it in the calculator is you're going to have, it'll be C equals obviously, but you won't put that in the calculator. So you'll have the inverse of A times B. Okay, so that'll be the inverse of matrix A times B. And you always want to make a little note on this because this is something that's very helpful. You always want to put your inverse first. Because you know that in matrix multiplication, the order matters. So if you put your inverse first, it's always going to give you the correct answer. If you put it second, it's not going to work. And I can go in through that another time on why it won't work. But just know for right now that anytime you do this, you need to make sure that you put your, you put your inverse first when you multiply. So we've got matrix A, and we're going to do the inverse. So that's when you hit your x to the negative 1 to get that inverse, and then multiply that by matrix B. And then it goes ahead and gives you your answer. So it's not as tedious as it is doing it by hand, because it just goes ahead and gives you the answer, and you don't actually have to find the inverse. You just plug it in and it'll give it for you. Okay, so now that you know how to do the inverse, I want you to try 16, 17, and 18 on your own. And then when you get done, unpause and I'll give you the answers to see if you got it right. All right, let me erase some of this here so that we can see. Okay, so on 16, all you had to do was multiply by the inverse of B. Actually, if you let this one be A and this one be B, you would be multiplying by the inverse of B because you want to get rid of that Y, or get it away from that Y. So Y equals 3, 9, and that's your matrix there. And then on 17, you would first, if this was A, B, and C, then you would first add B, and then you would multiply by the inverse of A, because you want to get it away from that X. So you would add because this is already negative, B is already negative, and then you would multiply by the inverse of A. So then you would get X equals -4, -10, 1, -4. And if you didn't get this one right, it might be because you put it in the calculator a little wrong, because you've got to think that you're adding A and B, or B and C first. And if they were regular numbers, then you would already combine those. So what you're doing is you have B plus C also, and then you multiply the whole thing by the inverse of A. So that's actually how it needs to be put in the calculator. You need to put A in there first, inverse of A first. You can put that multiplication symbol there. I think this one will work without it. But you need to make sure that you always put the inverse first, and that you have parentheses around whatever your first operation was. If I added B first, like I did here, then I need to make sure that it's in parentheses, and then I multiply by the inverse. Okay? So same thing on 18. If this was A, B, and C, then I would subtract C. And a lot of people are like, well, which way do I subtract it? Well, if you're subtracting C, then which one is negative? Well, obviously C. Okay? So you're actually doing A minus C. And then you would multiply by the inverse of B. Okay? So then in your calculator, you would do B inverse and then have A minus C. And that's going to give you your X. So then X equals, this is the matrix that you have, -3, -2. Okay, so hopefully y'all are actually enjoying putting these in the calculator. There again, Coach Howard teaches the same thing. If you need some extra help, I'm sure that he'll be more than happy to do it. He's usually here early in the morning. All right, That's it.